Good noon, everyone. First of all, I am very grateful to my respective professor as it gives me a chance to present something, and I am very thankful to my group mates as they had helped me a lot for preparing this presentation. So, I am Swaralipi, a student of Department of Physics of University of Kollani. Today, the topic of our presentation is production of low temperature. So I am very sure that you all are very familiar to this. So let's start the short discussion on it without any delay. Today I am going to share with you these corresponding topics: introduction, cooling techniques, though there are so many other processes, but I would like to share with you these topics: cooling by adiabatic expansion, cooling by Podolsky plug experiment, which is famous as the name of Joule-Thomson effect, regenerative cooling, Pomeranchuk cooling, and refrigerator as a compression machine, and refrigerator as an absorption machine, and summary. So we have to know at first what is low temperature physics, or why we need to attain low temperature. Low temperature physics is that branch of physics which is concerned with the measurement and the interpretation of the phenomena in low temperature, or we can say that low temperature physics is that branch of physics which is concerned with the production of low temperature. Atoms behave in some different way at very low temperature. The order of the system is increases and reduces the thermal noise which bothers the measurement. The quest for the production of low temperatures began essentially with our attempts at liquefaction of gases such as oxygen, nitrogen, helium. The ever-increasing interest in the production of low and lower temperature is due to many exciting discoveries that open up new frontiers in the study of matter and enriched our knowledge of magnetism, superconductivity, superfluidicity, Bose-Einstein and condensed state. Though I have not mentioned here, but low temperature has some practical application also. Liquid oxygen, which can stored in cylinder and uses in hospital as an artificial respiration. Argon gas is used as gas-filled electric lamps, as in refrigerators, fire extinguisher, fuel, and to produce high vacuum or study of properties of upper atmosphere. There is a lot of application of low temperature. So you can see that low temperature has some beautiful application in our daily life and basic science also. Let's move on to the next topic: cooling by adiabatic expansion. While studying the first law of thermodynamics, we learned that when a system is made to expand adiabatically, some of its internal energy is lost, and that results in the drop of temperature. For an ideal gas undergoing reversible adiabatic expansion, the temperature pressure relation is T to the power gamma by P to the power gamma minus 1 equal to constant. Now we can see that for two states characterized by temperature T1 and T2 and pressures P1 and P2 correspondingly, we have T2 by T1 equal to P2 by P1 to the power gamma minus 1 by gamma, where gamma is the adiabatic exponent. By calculation, we can see that delta T equal to T1 minus T1 in brackets 1 minus P2 by P1 to the power gamma minus 1 by gamma. Thus, the adiabatic expansion can be gainfully utilized for the production of low temperature. A slightly variation of adiabatic expansion is the Joule-Thomson effect by Joule-Kelvin expansion, which will be discussed in the following section. Podolsky plug experiment. In this experiment, the experimental gas is highly compressed by a suitable compressor and forced at constant pressure P1, which can expand adiabatically and irreversibly through a porous plug B fitting tightly in a tube A of poorly conducting material. By proper packing of asbestos, wool or other non-conducting materials, the tube is thermally isolated so that no heat can transfer, enter or leave the system. Such an expansion of gas is called a throttling process. Regenerative cooling. The principle of regenerative cooling is an useful technique for quick liquefaction of gases by Joule-Thomson expansion. In this method, at first a compressed gas is cooled by expansion through a constrictive nozzle and then reused for cooling the incoming gas in a heat exchanger before the latter is subjected to throttling. Here in the diagram, we can see schematic diagram for 4 different regenerative coolers. What is a Pomeranchuk cooling? This effect was first observed by Yuri Orunfriv in 1965. The another name of this cooling is cryogenic cooling. From this phase diagram of helium-3, you can see that Pomeranchuk cooling is the phenomenon in which liquid helium-3 will cool if it is compressed isentropically when it is below 0.3 Kelvin temperature and 29 atmosphere pressure. This occurs because, according to Clapeyron equation, the solidification heat of He3 is negative. And so, the entropy in the solid phase is greater than the entropy in the liquid phase. Let's discuss the new topic, refrigerator. Refrigerator is a heat engine operating in reverse direction. It is very familiar topic. Heat will be extracted from the low temperature reservoir and transferred to the reservoir at higher temperature by doing work done upon the system. The efficiency of the refrigerator is measured by what is called the coefficient of performance omega. Omega equal to Q2 by W, where Q2 is the amount of heat which is extracted from the cold reservoir and W is the input work done. Let's see the new topic, refrigerating machines. Here is 2 types of refrigerating machine. One is vapor compression machine or Frigidaire and vapor absorption machine or electroless refrigerator. Frigidaire. It is a domestic refrigerators belong to this type. Here the liquidable SO2 is used as the refrigerant and it consists essentially of a condenser C, evaporator R or refrigerating chamber R, mechanical pump or compressor P, controlling valve V. This is the schematic diagram for Frigidaire refrigerator. Here from the evaporator, the saturated or superheated vapor which is in low pressure goes to compressor and the work done, some work done is upon the system is given. Then it goes to high pressure and it becomes this saturated vapor become the superheated vapor and goes to the condenser and thus saturated and subcooled liquid goes to expansion device and from expansion device in low pressure goes to compressor and the work done, some work done is upon the system is given. Then it goes to high pressure and it becomes this saturated vapor become the superheated vapor and goes to the condenser and thus saturated and subcooled liquid goes to expansion device and from expansion device the liquid or vapor mixture go to then evaporator. Absorption machine or electroless refrigerator. To remove the compressor or motorized system that is in Frigidaire, such type of Frigidaire makes use of properties gas, vapor mixtures. If a liquid is exposed to an inert atmosphere, here hydrogen gas, then the liquid will evaporate. And for this evaporation requires heat which is taken from the surrounds. A cooling effect is thus produced. So now we come in our last discussion, summary or the drawback of low temperature. By now it is realized that it becomes increasingly more and more difficult to attain progressively lower and lower temperature, as third law of thermodynamics states that it is impossible to reduce an assembly to the absolute zero of temperature by any thermodynamic process, however idealized, in a finite number of operations. So that concludes my presentations. Thank you.